start. Only 43. Where are others? Yeah. So how long to wait? So we'll start. Yesterday we have completed with the first unit. So today we start with second unit. The second unit is almost the same as, some contents are same as your first unit. So in the last first unit, we have seen what are the classes and methods. There is small repetition again in this unit. So we'll see what is the methods and the classes once again. So what in that, how do we control access to the class members? So what is the access controls we have? So Java provides a number of access modifiers to set access level for a classes, variables, methods, and constructor. The 4 access levels are visible to the package, the default, no modifiers are needed, visible to the class only, that is private, and visible to the world, that is if it is a public, and visible to the package and all subclasses if it is a protected. So these are the 4 access levels available in Java. One is visible to the package, that is the default. No modifiers are needed. If it is a default, then it is visible to the package. So the visible to the package, the default, no modifiers are needed. Visible to the class only if it is a private. So if you are declaring the access specifier as private, then it is visible only to the class. And if you want everyone to see, then we give it as a public. And if you want only for package and subclasses, then you give it as a protected. These are the 4, 3 and 1 default, which is if you don't give anything, it will be taking it as a default. Okay, so default access modifier, no keyword. So that's what, when you are saying a default access modifier, there is no keyword. Default access modifier means we do not explicitly declare any access modifier for a class, field, method, etc. A variable or a method declared without any access control modifier is available to any other class in the same package. The field in an interface are implicit, public, static, final, and methods in an interface are by default public. Example, variables and methods can be declared without any modifier, as in the following example. So string version 1.5.1. So then Boolean process order, it will return if it is true. If it is not, then it will not. So this is one example. The next one, we move on to a private access modifier. So we have just seen when do we use a private access modifier. A method, variable, and constructors that are declared private can only be accessed within the declared class itself. So what do we say about private? A method, a variable, and a constructors that are declared private can only be accessed within the declared class itself. Private access modifier is the most restrictive access level. Class and interface cannot be private. So private access modifier, private, what we do here, methods, variables and constructors that are declared private can only be accessed within the declared class itself. So private access modifier is the most restrictive access level. Class and interface cannot be private. So private class modifier is the most restrictive class level. So class and interface cannot be private. So we cannot give class and interface as a private. So variables that are declared private can be accessed outside the class if the public getter, that is better method, are present in the class. Using the private modifier in the main way that can object encapsulates itself and hides data from the outside world. So how do we use variables? Variables are declared private, then access outside the class is not allowed. So in the same way, using a private modifier in the main function, the object encapsulation itself and hides data from the outside world. So the following example for using a class access modifier, class public class name of the class is logger. So then we have given private data type string and the format is a variable. So in the same way, we have given public string get format, that is for a method. We have given it as a public. So then public void set format, this is also a method set format, and we have passing a string format to this function. Then this dot format equals to format. So we can see how the because within a class only, this we have to use this for, we are using a this and the format, that variable we are using in a get method as well as in a set method. Here the format variable of the logger class is private, so there are no way for other classes to retire or set its value directly. So to make this variable available to the outside world, we defined two public methods. One is get format, which returns the value of the format, and a set format within one variable string, which sets its value. The public access modifier, that is if you give it as a public, a class, method, constructor, interface, you give for anything. Either you can give it for a class, or you can give it for a method, or it is a constructor or interface. Declared public can be accessed from any other class. Therefore, fields, methods, blocks declared inside a public class can be accessed from any class belonging to the Java universe. However, if the public class we are trying to access is in a different package, then the public class still needs to be implemented. Because of the class inheritance, all public methods and variables of a class are inherited by its subclasses. So how, if we give public, what is happening? If we give access modifier as a public, so then what it is happening, whether you can give for a class, or you can give for a method, or you can give for a constructor, or you can give for a interface, declared as if you are declaring it as a public, can be accessed from any other class. Therefore, the fields, methods, blocks declared inside a public class can be accessed from any class belonging to Java universe. However, if the public class we are trying to access is in a different package, then the public class still needs to be imported because of the class inheritance. All public methods and variables of the class are inherited by its subclasses. So example for access, how to declare access control. So the following function uses a public access control, that is public static void main, then string and argument. The main method of an application has to be public, otherwise it could not be called by a Java interpreter. to run the classes. So the main method of any application has to be public. Otherwise, it could not be called by a Java interpreter, such as Java. So to run the class. So this is a syntax. The main method of an application has to be public. Otherwise, it could not be called by a Java interpreter, such as to run the class. So that's what we cannot change the access specifier for a main function. So always it should be public. So protected access specifier, variables, methods, constructors, which are declared protected in a superclass, can be accessed only by the subclass in other package or any class within the package of the protected members class. So the protected access modifier cannot be applied to class and interface. Methods fields can be declared protected. However, methods and fields in an interface cannot be declared protected. Protected access gives the subclass a chance to use the helper method or a variable while preventing a non-related classes from trying to use it. So we can see here the following parent class use protected class control to allow its child class override one speaker. So here what we have done, so class audio player protected. So the method open speaker is a protected and we implement that. So then class stream audio player extends audio player, means extends when we have to use, when we are using a base class properties to a derived class, then we have to use a keyword called as a extends. And audio player, so this is a method, this is a class, base class, and streaming audio player, this is a base class, derived class. So Boolean open speaker, so we want to take a method Boolean open speaker from a base class to the derived class. So that's what here we have done. So here if we define an open speaker method as a private, then it could not be accessible from any other class other than audio player. So if we define it as a public, then it could become accessible to all the outside world. But our intention is to expose this method to its subclasses only. That is why we have used protected modifier. Then access control and inheritance. The following rules for inherited methods are enforced. The method declared public in a superclass also must be public in all subclasses. So in some properties for access control, the following rules for inherited methods are enforced. The methods declared public in a superclass also must be public in all subclasses. Methods declared protected in a superclass must either be protected or public in subclasses. They cannot be private. Methods declared private are not inherited at all, so there is no rule for them. So modifiers are keywords that you add to those definitions to change their meaning. A Java language is a wide variety of modifiers, including the following: Java access modifier, non-access modifier. To use a modifier, we include its keyword. In the definition of a class, method, or variable, the modifier precedes the rest of the statement, as in the following example. So then, Java provides a number of access modifiers to get access level for a class, variable, methods, and a constructor. The four access levels, what we have discussed, visible to the package, the default, private, public, and protected. So the non-access modifier, what are the non-access specifiers? Java provides a number of non-access modifier to achieve many other functionalities. The static modifier for creating class, methods, and variables. The final modifier for finalizing the implementation of class, methods, and variables. The abstract modifier for creating abstract class and methods. The synchronized and volatile modifier, which are used for threads. So that's what non-access modifier. Java provides a number of non-access modifiers to achieve many other functionalities. the static modifier for creating class methods and variables. So the final modifier for finalizing the implementation of a class method and variable, and the abstract modifier for creating abstract class and methods, then synchronized and volatile modifier which are used for threads. So these are the different non-access modifier. So we know about public, private, protected, and default. So these are the four which are access controls in the Java, and which are non-access controls. One is static, final, abstract, synchronized, and volatile. These are the five non-access modifier. So what is a static modifier for creating a class, method, and a variable? So why do we use a final modifier for finalizing the implementation of either it may be class, method, or variable? Then abstract modifier for creating abstract class and a method. Then synchronized and volatile modifier which are for a threads. So if you have a threads, then you can use a synchronized and a volatile modifier. So how is the access levels for all the different modifier? We know public, private, and default, no modifier. So then a private. So if it is a class, so all these public, either it is a public, protected, or private, or no modifier, it is accessible. So then package. So when we say package, so if you're declaring public, yes, it is accessible. Protected, yes. No modifier, yes. But private, if you're declaring your access levels as private, then in a package you cannot access. So then subclasses, only public and protected can be accessed if you're declaring it as a public. And if you're declaring it as a no modifier and private, then it cannot be accessed. So in the same way, if it is a public, it can be accessed. If you have declared public, everyone can access. Then protected, no, we are not able to access. Then no modifier, no, we cannot. Then if it is a private, then also no. So that's how about access levels, brief summary about how the access level, if it is a class, if it is a package, if it is a subclass, and if it is other different classes. So if you want to access, then how it is. Okay, the first data column indicates whether the class itself has access to the member defined by the access level. As you can see, a class always has access to its own members. The second column indicates whether classes in the same package as the class, regardless of their parentage, have access to the member. The third column indicates whether subclasses of the class declared outside this package have access to the member. The fourth column indicates whether all classes have access to the members. The next we move on to the passing objects to the method. So which we have already seen in the first chapter, but still we see how we are doing it. So the object reference can be parameters. So how the objects, either it can be parameters or it can be objects. So then we call by value is used. But now the call, the value is an object reference. So this reference can be used to access the object and possibility change it. Here is a small program. What we see, how do we pass objects to a method? So we have a class called as a public class rectangle. So in that we have taken two variables, double, length and width of data type double, and access, so we have made it as a private. When we say private, it is only accessible within this particular class, within this particular program. So then we are using one constructor called as a rectangle, and length and width we are initializing it as a 0. So the same way, one more constructor rectangle where we are passing two variables, that is length and width with data types as double, and we are passing this length and width. So then we are taking one more method called as a set length. So the data type we are passing it as a double, and we are setting the length. The same way, set width, we are taking one more method and we are calling it as a width. The one more method called as a set, where the two length and width we are setting both of them. So then get length, where if you want a length, we are using a get length method. If you want a get width, then we are using a get width method. if you want area of area, so then we are using a get area. In get area, we are multiplying length into width. So then the last one, get perimeter. So perimeter formula 2 into length plus width. So then that will get us a perimeter. So then you can see in the rectangle we have used access modifier as public. So in the same way here also in this constructor, this is a no arguments passed in the constructor, and here we have passed a constructor with the two variables, that is length and width, and the public. So then again here also set length where it is not returning anything, but still the access specifier is a public. So then set width, again access specifier is public. So again set it is not returning anything, but still it is a access specifier is public. So then double get length, so then public, that is what it is returning something, then public double and get length. So then public double and get width. So this is what return width. So public double get area. So return length into width. So public double get perimeter. So this is a length of the uh, perimeter. Then we are passing a object. So we are creating an object. RECT is an object we have created, and we are passing length and width value as 10 and 20. And we are displaying first length. So then we are saying rect dot created an object, but we are calling a method called as a get length. So the same way we are calling a width. So created object with width. Then created object rect RECT object, and calling a method called as a get area. So we are just displaying the contents. So in the same way here, passing the objects to change the rectangle method. So what we are doing are we have passed change rectangle. This is the object we are passing. So then again we display the same thing after the object is being changed, display them. So then we have to create this is one more change rectangle value, and we are passing an object rectangle and R. So what is the size we are passing here? For the length and width we are passing 10 30 and 5. So first initially these two lines, so we know we have passed 10 and 20. So length is 10, width is 20. So here we have passed 10 and 20. Length 10, width 20 is passed. And here get area, what the get area is doing, get area is multiplying length into width. So 10 into 20 is how much? 200. So that will be displayed here. Okay. So next what we are doing, we are changing the size of the rectangle, but how? Through the object. So through the object, what we are passing length value as 30, and this is 5. So now length, so what is the length now? 30. What is width is 5. So then multiply these two, that's what here we want, get area. So then 30 into 5, so that will be 150. So this is the area after change of the size of the rectangle. But how we are doing it? We are passing an object here. You can see RECT is an object where we have created, and that we are changing. Okay, so next parameters and arguments. Information can be passed to methods as parameters. Parameters act as variable inside the method. Parameters are specified after the method name inside the parenthesis. You can add as many parameters as you want. Just separate them with a comma. The following example has a method that takes a string called fname as a parameter. When the method is called, we pass along a first name, which is used inside the method to print the full name. So we can see here we have passed a main, and we are using one method called as a my method. In this we are passing a data type as a string fname, and we are just printing here. So then what we are passing in this method first name. So first time we are passing Lima, Jenny, and age. So these values will be printed here. So that's what, how do we write a program for this is one. So the same way my method we are passing, and we are just printing the all these with the reference. Here we are combining these two. So here we have just passed the same thing here. So how the program is working. So the output will be like this. Multiple parameters. So I want to combine multiple parameters in the method. So then one method, my method is having a string first name and its age, int is a age. So then f name is age. So public static void main string argument, my method 5. So my method Jenny 8, my method, and here what we are doing, we are passing two, first name as well as their age. So and it will be displaying both. So how that is working, so that's what here you can see. Always my method we are passing the values here, my method we are passing the values for both the string as well as integer. So this is called as a multiple parameters passing through the objects or through the methods. So returning objects from a method, like any other data type, date data types, methods can return a object. For example, in the following program, makes a twice method returning an object in which value of instance variable is two times that it is in the invoking object. So we can see here. So class, the name of the class is sample, and the date access modifier we have given it as a public. So here the access modifier for the value we have made it as a private, and the data type is integer. And the constructor name, we are passing one value for this constructor as I, and we are making data access modifier as public, and I is passed to the value. So then public sample make twice, sample temp equals to new sample value into 2. So we are making uh, uh, make twice, so calculating that value into 2 and return that in a temp. So then displaying, we are using the show method. So then public class return object demo. So then we are calling public static void main string and the argument. We are passing the object 1 and object 2. So object 1, so what is the value we are passing for I? We are passing it as a 10. So then one more object we are creating object 2. So object 2 equals to object 1 into make twice. So 10 is a value, make twice what we are doing, 10 into 2 is 20. So 20 will be displayed. So here this is what is called twice, demonstrates how the method can return a reference to an object. Next one, we have seen about a method overloading. With the method overloading, multiple methods can have the same name with the different parameters. So here you can see how the different methods have been different parameters. So we already seen in the first unit what is method overloading. Method overloading is what, the same name, same, it can have a same name, but at least there should be a different in either in the data type or in the parameters, number of parameters what we are passing, or it can be a different in the data types. These three things should be there, then we call it as a method overloading. So in this example you can see there are three methods with the same name, my method, my method, my method, but you can see the data types for the first one is integer, and this one is a float, and my method, the third one, it is double. Along not only that, you can see the parameters what we are passing, we are passing x of data type int, and here x we are passing the data type as float, and here also x and y is passed to a double. So here x is a double, y is a double. So that's what here we are passing them. Okay, so small program for this static int plus method int. So we are passing the two parameters x and y, and we want to return it. So we are adding x plus y and returning them. So then we are using one more method, uh, pulse method, double. So here also we are passing x and y, but with a different data types, double, and we are again adding and returning them. So again, the main method plus method, what is the value we are passing for the integer? We are passing 8 and 5. So that we are passing into a object called as a my number. So 8 plus 5 is how much? 8 plus 5 is how much the value?
13.
Okay. So then 4.3 plus 6.26 is how much? 4.3 plus 6.26 is how much? Yes, how much is the addition of the 4.6? 4.3 plus 6.26. Can anyone? If you add, how much is the value for these two? 4.3 plus 6.26. Yes, can anyone give the answer?
7.56.
Okay, so that is the value will be displayed here. The first one my number, and second one my number. So number 2. So here this object, first object will be adding 8 plus 5. Second object will be adding double, because we have used here as a double 4.3 plus 6.26. So this addition will be added and displayed here. The same thing here we can see 13, addition of this one. So then addition of double is, so I told 4.3 plus 6.2. If we are making it as a fraction, then we'll get 10.55, something like this. So this is the output of this number 1 and my number 2. So my number 1 is addition of 8 plus 5, and my number 2 addition of 4.3 plus 6.26 value. So static int public method int x int y. So then it will return. So here also we are returning. So the same program again we have just used here. Okay. So next we move on to a constructor overloading. So we've seen, did we see constructor overloading in the first chapter? Yes, we have seen, but again they have mentioned in even in the second unit also. So we have to redo it. So in Java, constructor is just like a method, but without a return type. So it can also be overloaded like Java method. Constructor overloading in Java is a technique of having more than one constructor with different parameter list. They are arranged in a way that each constructor performs a different task. They are differentiated by the compiler by the number of parameters in the list and their type. So that's what is a constructor overloading. So here in the constructor overloading, so class student 5, int integer, what is a variable id, string we are passing it as a name, int age we are passing. So then constructor we are creating, then what are the values we are passing, how many arguments we are passing two arguments. One is of data type integer, another one is with the data type string. So then I is taking id, n is taking a name. And we are creating one more constructor with three parameters, that is I, n and a. So I is integer, n is string, a is integer. That's what id passed, n name, and a is age. So like this we pass a constructor for this. So then display them. So that's what I want to display, id, name, as well as age. So that is being done in a method called as a display. So then, so here first constructor, first object is being created with the name s1, and where we are just passing two parameters, 111 and current. So it will take this constructor. And the second object we are creating, where we are passing three parameters, 222, aryan, and 25. So it will take this constructor. And display, so s1 dot display, again in this display it will be displaying only 2 because 2 parameters are passed. In display one more, display 2, so it will be displaying all the 3. So that's what here you can see. Instead of age, it will be 0 because we have passed only id and name for the first one. So it will be displaying id and name, and this will be 0. Then one more, object 222, so then Aryan and 25. So here we are passing 3 objects. It will be passing a 3 objects. Okay, so next, difference between constructor and methods in Java. So can anyone say what is the difference between constructor and a method? What is the difference between constructor and a method? Can anyone give me the differences between constructor and the methods in the Java?
Constructor have same as name as class, same class name, but method have different name.
Okay. Okay, good. One difference. Some more differences. Can anyone say? Good difference he has told. Next. What is the next difference? Yes, can anyone say what's the next difference? Other
We
than what
don't have to call constructor. When we create an object, it calls by
automatically.
default.
Okay, good. So one more, he is saying that we are not required explicitly call the constructors, whereas methods we have to call it. Okay. One more. Good. Next. Yes, anyone? Add some more points to this existing. No? Okay.
Constructor doesn't have return type.
Okay. So constructor doesn't have return type, whereas method has a return type. Okay. So we'll see them what is the difference between constructor and Java methods. So there are many differences between constructor and methods. They are, constructor is used to initialize the state of an object, whereas method is used to expose the behavior of an object. A constructor must not have a return type. So that's what someone has told. A method must have a return type. The constructor is invoked implicitly. The method is invoked explicitly. That's what here it is not required for us explicitly when we are using a constructor, whereas with respect to method we have to. So then Java compiler provides a default constructor if you don't have any constructors in the class. The method is not provided by a compiler in any case. That is also one thing where if we are not defining the constructors, so the compiler will default, it will take. So the constructor name, yes, someone has doubt? Okay, the constructor name must be same as the class. So one you have told, yes, that's also right difference. So always we know that when we are saying a constructor, it should be the same name as a class. So the method name may or may not be same as the class. So these are the differences for class, for your Java constructor, a difference between a constructor and a method. So I'll stop here. We'll continue in the next class with the recursion. So before we end, so difference between constructor and method has been pointed like this. A constructor is used to initialize the object of an state of an object. A method is used to expose the behavior of an object. A constructor may not have a return type. A method must have a return type. Uh, Constructor is invoked implicitly. The same thing, the method is invoked explicitly. The Java compiler provides a default constructor if you don't have any constructor in the class. The method is not provided by the compiler in any case. The constructor name must be same as the class name. The method name may or may not be same as the class. So we'll stop here. So this is a difference between the constructor and the method. So before we start, we just summarize what we have done today. So we have started with the second module today. So then the second module, first they say what are the, we just go in depth about a method in the class. So then we have seen what are the access specifiers available and available in Java, and what are they. So there are 4 access levels. One is default, where we don't use any keywords. Then that is what is called as a default. Next one, we use a class. We use a private, where what is the visibility of a private? It is visible only to the class. When we declare it as a public, it can be accessed by anyone. So then when we declare it as a protected, it is accessed only within that package and a subclass. So this is about access modifiers in the Java. So there are 4. One is default, private, public, and protected. So then we have seen default access modifier, there is no keyword, and we have seen one example. And private, where it can be accessed only if it is the restriction, most restriction, and it is generally told that if you want, don't give for a class and an interface as a private, because class, if you give private, and then it will be difficult for creating an object. There will be so many difficulties. So they say whenever you are using a private, use it very carefully. So then this is one example for a private. So then we have started with public. Public can be accessed by anybody, within a class or within the package can be accessed. And this is a syntax what we have used. And always one more point we have to remember, for a main method, you cannot give it as a private protected thing. It should be public. So the main method, whenever we are using, it should be public. That is one restriction or one point we have to remember. So then next one is a access, one more access modifier, that is protected. So when could we use a protected? So when we don't want to give for complete everyone, we want to restrict only for our family members, something like that, is use a protected, means only from base class to the derived class. So in that case, we use a protected. So this is an example for protected. So then how the access control and inheritance are used. Then we have just seen access modifier. Then we have to see what are non-access modifier. The same slide again repeated. What are the access modifier? We know that is default, private, public, and protected. What is non-access modifiers? Static is non-access modifier. Final is a non-access modifier. Abstract is non-access modifier. Then synchronized and volatile. So these are the non-access modifiers, but still they are modifiers, but they are not access. These things will not come under access. But static is also a modifier, final is also a modifier, abstract is also a modifier, synchronized and volatile is also a modifier. Then we have seen how the access levels at a different places. When you declare it as a public, what happens if a class with a package, with a subclass, with the world? If it is a protected, what is happening with the class, package, subclass, and a world? If we say no modifier, then what happens with a class, package, subclass, and a world? So this is a just summary of all the modifiers. If it is a class, if it is a package, if it is a class, if it is it can be accessed by everyone. So that's how here we say. So then we have seen what is the first column says, what is second column, what is third column. And next we move on to the passing in objects to the methods. So call by value, we know we have seen call by value and call by reference. Call by value means if you're just passing values to the methods. So when you're passing a reference objects, then we call it as a call by reference. So that's what we have seen in the first unit also. And here we have started again seeing how the values have been taken. Here we have created in constructor with no parameter, constructor with 2 parameters, a method, one method with passing length, one method with passing width, and one more method where 2 length and width are passed, and one method to get the length, one method to get a width, and one method to calculate the area, and another method to get a perimeter. So here we have a get length, get width, get area. Then we are calculating that. change the values. Initially, we have given 10, 20. Then we are changing values and passing to the objects, that is 30 and 5, and redisplaying them. So then we have used how the parameters and arguments are being done. So this is how we have seen the parameters and how the program will be displayed. Same way, here multi-parameter. Here we have passed only one parameter, that is string type, and here we are passing string as well as integer and displaying how the program is being written. Then returning object, how does the return object works? So we have seen this program where 10 is been passed for one object, and the same 10 is passed to the one more object where we are multiplying that with 2 and getting a value. So method overloading we have started. So method overloading, same name, but you can have same name for a method, but at least what should be different? Return type should be different, data type should be different, number of parameters what we pass should be different. So that's what in these three methods, the name of the method is my method, but the return type for one is int, float, and double, and parameters are x, y. So first is integer, second one is float, next is xy is double. So then here we are passing 8 and 5 for a method, and 4.3 and 6.25 for a method. This has been displayed here. The same is being displayed here, the same program. So then we have started with a constructor overloading. So here you can see there are two constructors, one constructor with 2 variables, one more constructor with 3 variables, and displaying them. So that's what we have done in this part. And finally, we have stopped with the differences between Java constructor and a Java method. And in the next class, we'll see what is a recursion. So afternoon you have lab, right? Yes. So Anaga, answer your attendance. Anaga.
Yes, ma'am.
Abhilash.
Yes, ma'am.
Akshay. Sorry, Akash. Akil.
Yes, ma'am.
Akrut.
Yes, ma'am.
Anusha.
Yes, ma'am.
Arvind.
Present, ma'am.
Arifullah.
Yes, ma'am.
Benaka.
Present, ma'am.
Yes, ma'am.
Banu Prakash. Bhargav.
Yes, ma'am.
Bhargav.
Yes, ma'am.
Rahmatullah.
Present, ma'am.
Chaitra.
Present, ma'am.
Chandana.
Yes, ma'am.
Charan.
Yes, ma'am.
Darshan.
Present, ma'am.
Diksha.
Present, ma'am.
Dakshayani.
Present, ma'am.
Kishan. Present. Harshit.
Present, ma'am.
Hemalata.
Present, ma'am.
Hemalata. Uma.
Present, ma'am.
Jayant.
Present, ma'am.
Divya. Divya. Kaushik.
Present, ma'am.
Lakshmi.
Present, ma'am. Mic issue.
Lavanya.
Mic issue, ma'am.
Manish.
Present, ma'am.
Manoj.
Present, ma'am.
Mohit.
Yes, ma'am.
Naval.
Present, ma'am.
Navya. Nikhil.
Present, ma'am.
Panindra.
Present, ma'am.
Pavan. Pooja.
Present, ma'am.
Purnima.
Yes, ma'am.
Raman.
Yes, ma'am.
Rashmi.
Yes, ma'am.
Rupak.
Yes, ma'am.
Sai Kumar. Sai Kumar. Samir.
Present, ma'am.
Santosh.
Present, ma'am.
Sadab.
Present, ma'am.
Charan.
Present, ma'am. Network issue.
Shashank.
Present, madam.
Sheetal.
Present, ma'am.
Shivani.
Present, ma'am.
Soumya.
Present, ma'am.
Spurti.
Present, ma'am.
Shri Vishnu.
Present, ma'am.
Sugandhini.
Present, ma'am.
Sushma.
Present, ma'am.
Sushmita.
Present, ma'am.
Sushmita you.
Present, ma'am.
Tirtha.
Present, ma'am.
Trupti.
Present, ma'am.
Trupti. Varsha.
Present, ma'am.
Veena.
Present, ma'am.
Okay. Hemlata marked. Anybody else? Yes? Any doubts? So we'll stop here. We'll continue in the next class. So today afternoon you have lab. So which program we have to start? Which program? Can anybody say? How many programs you have completed?